Hi, I'm following along with Paul McWhorter's Pico W lessons, and I've taken a bit of a break from his lessons, but here is my solution to lesson number 50, creating the ultimate pitch and roll gadget using an MPU 6050. I've kind of done my own thing because I was finding them going a bit too slow in Paul's lessons. I've got a low concentration level, or whatever you call it. The one way to beat me at chess is to just take too long to take a move. I can only play speed chess rather than ordinary chess because it just annoys me too much. Anyway, here's my solution. I'll just explain what I'm doing. It includes a magnetometer, because I would have preferred if the Sunfounder kit had an MPU 9250, I think it is, instead of the MPU 6050, because the other one does include a magnetometer. Now I'll tell you what this solution does, so you won't have to watch all the video if you don't want to. It includes calibration of the MPU 6050 and the BBM105 it's called, which is a magnetometer, because as a lot of people say, calibration is not optional. It's no good fudging the results afterwards, especially as I really don't like hard coding values in the code, because these might have to be changed if you were using a different sensor or a different location. And apart from the calibration, I also needed to do magnetic declination on the magnetometer, which is because magnetic north isn't in the same place as true north, so you have to go to do various things to work it out, and you need your latitude and your longitude and the year, because it moves from time to time. And for that I had to use 3 APIs to get all the information. Of course, all this doing the calibration and the declination and everything like that takes quite a long time. So I've also included an option that when you do it once, the next time you then save all the values to a file, and the next time you can either choose to do it all over again, or you can just read the values in the file. And what else have I... and also, because I don't like values hard coded in, I've also done all the positioning of the text on the OLED, worked out from the size of the OLED screen rather than just guessing. And I've included big font, as explained in my video that I called Changing Font on OLED and Pico W. I'm also displaying degrees as degrees, minutes and seconds rather than 15.143 degrees, and I've also got a way of finding out the heading, as in north, northwest, southeast, south, without loads of if statements. And I'm using 3 devices on the same I2/3 bus. So that's what I'm doing. So shall I demonstrate it, or shall I? No, I will show the code first. Right. To get the declination, first of all, in fact, I will demonstrate it first, because then if you aren't interested in this, you can just go away. I won't be offended. Right, so I will demonstrate this program. I will run it. It's saying getting this takes a time. Whoops, it would be better if that window was slightly bigger than. Right, press enter to start calibrating of, it would have been calibration of magnetometer. Move it in figure of 8, so you click there. And here's my magnetometer. And if you move it in a figure of 8, it ought to give you some readings. But I am so close to so much magnetic stuff that it might not work very well. Right, so here I am, and I'm going to move it in a figure of 8 like that. So I'll press enter, and I'll start going in a figure of 8, figure of 8, and figure of 8. I'm kind of, it's very difficult to show. Right, I can't do the filming and the figure of 8. Now this is very boring, very boring, very boring. And it might not achieve. You can stop now. Press enter to start calibrating the MPU. Right, need to leave that nice and steady. Press enter. Don't move it. Right. Now that heading is the way that the magnometer is pointing, and it kind of isn't that great. It's roughly where it ought to be. I haven't done a huge amount of checking on it, but we'll forget that. So back to the whole point of this. Can I get this to show nicely? I will try. You can, it looks quite good in real life. If I go really close, what does that do? No, 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 no. But further away, sorry about this. Right, well, I can't really get it to show very well, but that says P2 in nice big writing and R37. So the bubble moves if I move it like that, if I move it like that, if I move it like that, and the bubble doesn't go out of the screen. So it's got a maximum of 90 degrees each way to do it. So I can go right like that, and that is pitch 57, and that's just how it is. So if I stop this program, I've got an option down here which says calibrating equals true. If I just change this option to calibrating equals false, oops, not falsy, false, and run it, there you see we're getting all the details from the file that I saved them to, and things are still working fine. Now I stop the program. If you aren't interested in my code, you can go away. Maybe everyone's gone away already. Right, I will just explain. Now to get the declination, first of all I use that API IPIFY, and that got my location. And then once I got my location, I used another API to get my latitude and longitude, and then I needed to use that API to get the magnetic declination. Now I've put in the latitude, the longitude. The altitude, I couldn't find a way to find out, apart from I got it from my car's GPS. And the year needs to be, because it's moving all the time, the magnetic north is moving all the time, need to be a decimal year. So what I've done is I've taken the year and then I've added on the year day, which is like the day in the year. So the 21st of February is 52, for example, and just divided it, and that's given me the year as in 2024.1 or whatever. So then I get that, and I've just got the declination. And to calibrate the magnetometer, I've lifted all this code from something by Mika Tupola, who's very clever, and you just take the maximum and minimum and it ought to do something. The only trouble is I've got so much equipment. I've got speakers, I've got a phone, I've got the monitor, I've got my computer, I've even got my electric toothbrush plugged in by it. So this is why maybe the results won't be very good. Right, then to get the calibration, I'm just holding it still for the whole kit and caboodle, the board with the MPU 6050, and I'm taking lots of readings like that, and then I'm averaging them out. And then after I've done all that, the calibration of both things and the declination, I'm now saving all the values to a JSON file, and then I'm returning that to the main program. And while I'm here, if I'm not calibrating, I'll just get all the values from the file. When I'm displaying the heading from the magnetometer, that is just an easy way to get the degrees in degrees and minutes and seconds. And this is just a list. It has to be a list, not a dictionary, of all the headings, and you can find out by the angle which one you're doing, as opposed to saying if the angle is blah 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 is north, if the angle is less than that and greater than that, then it's that. Then it's very boring, so I don't have to do that. Right, I'm using one I2C bus because I'm using the addresses. I have shown on a previous video how you can get the addresses of the devices. I can show just this program that I showed before. If you want to see what devices are connected, this program will do it for you. Right, back to my program. Right, so I'm doing all of that. Then that is all to do with setting up the grid, the coordinates of the grid, rather than just saying, oh, I'll guess that the top's there, the bottom's there, whatever. And that's for my bubble. That's about the only thing I have hard-coded in values. Then calibrating. If I'm calibrating, I do all the calibration stuff. If I'm not calibrating, I get the values. That's just for debugging. And coming down here, I've set up all these values, which mostly are to be used for when I'm doing a low pass filter. Then in the while true loop, I'm setting the start time before I do it, and I take the acceleration, the gyro and the magnetic, and then this bit here is just to do the low pass filter. And on the magnetometer readings, I am including the details that I got from my calibration. Set up the pitch, the roll, and then here I'm combining the pitch from the gyro with the pitch from the roll. No, the pitch from the I'm combining the roll from the gyro and the roll from the accelerometer, and the same thing with the pitch to kind of hold the values together. And then the rest of this is all writing to the LED, which is all very simple. And I'm using, as opposed to manually drawing a circle, I'm actually using the ellipse function. Because if you make the two radii from in the ellipse function the same, you end up with a circle. Right, then every 10 readings I print out the data from the magnetometer and say which direction it's in, and there we have it. And as I printed out, that CHR hex 20 times 19 means that I'm printing out 19 characters, so I never get the end of the line done. Right, that's my code. Oh, and of course the stop time and the loop time, I'm just using it so I can work out where is it? There, to work out the gyro pitch values. So there's my program. I wanted to do it without watching any of Paul's videos after about lesson number 45, because I wanted to see if I could do it myself.